All right, here we go. We got lesson 11.2, solve by completing the square. So our question today is, how do you know if the solution to your equation has no real solutions, or roots as we call them? Okay, so we always know that there are going to be some solutions. There has to be some solutions. Just some of those solutions aren't real. They're not real numbers. They're not found on the number line. And we'll get more to that later. So we're just going to start with some examples here, because in the last section, you're converting from standard form to vertex form, and we're going to use the same process that we used with completing the square. So let's look at our first problem. Example 1. We're going to solve x squared minus 10x minus 36 equals 0. And this one we can see again, like the things we were doing on the last lesson, it doesn't factor, so we can't set our factors equal to 0 because there are no factors of negative 36 that add up to negative 10. So in the last unit, we would have been stuck here. We couldn't have solved this. But now we can because we have completing the square. So when we complete the square, we're going to start by moving this value to the other side of the equation. So that's our C value. We're moving it to the other side of the equation. It's the exact same steps that you took on the last lesson to convert from standard form to vertex form. The only thing that's different is this 0 here. On the last lesson, it said f of x. But now we're actually solving for the x value. So we're taking out the y value because we're not going to worry about graphing about it until the end of this lesson. So we've moved that over. That yields x squared minus 10x. I'm going to leave a little bit of a blank here because I'm going to need that in a second. Equals 36. And then I'm going to leave a blank there. And what's going to go into that blank is the number that completes the square. And we found out on the last section that to complete the square, we took the b value, which is the negative 10. We divided it by 2, and we squared it. So negative 10 divided by 2 is negative 5. That negative is important, so we're going to leave it there. And then square it. And then negative 5 squared is 25. So 25 is the number that we need to complete the square. So we're going to add 25 to this side of the equation. And we're going to add 25 to this side of the equation. We have to add the same numbers to both sides because the addition property of equality says if we add one number to one side, we have to add to the number side. Now we're going to do the same process we did yesterday. We're going to simplify this side, and we're going to make this into a binomial square. So over here, we're going to change it into x. And then we got to figure out what number is this a binomial square of. Well, over here, we squared negative 5. So this is the binomial square of x minus 5 squared. On the other side, we've got 36 plus 25. That should give you like, I don't know, 61-ish. Yeah, that sounds good. 61. All right. Now we're at a point that we were at in the last unit where we're solving using vertex form. What we found out in that unit is one thing that we can do is we can take the square root of both sides of the equation in order to solve. So I'm going to take the square root of this side. I'm going to take the square root of this side. So remember, square rooting cancels out squaring because they're opposite operations. So this side of the equation is going to turn into just x minus 5. On the other side of the equation, remember, whenever we take the square root of both sides, we have to add plus or minus. So we got plus or minus on this side, and then root 61. Now root 61 is not going to simplify. It doesn't have any pairs in it, so I can't bring anything out. So I'm just going to leave it as root 61. We're almost done. All we have to do now is add 5 to both sides of the equation. So I'm going to add 5 here, add 5 here. On the left side, this is going to yield x. On the other side, I've got this 5 that I added to both sides, and then plus or minus root 61. So that's the solution to our equation. We've got two answers there. One of them is 5 plus root 61. And root 61, I don't know, it's close to root 64, so it's like 7 point something. We're not going to worry about that. We'll just leave it as, so this could be 5 plus 7 point something and 5 minus 7 point something. But since this is a irrational number that's going to go on forever, we're going to just leave it as a radical there. So it's 5 plus root 61 is an answer, and 5 minus root 61 is an answer. Remember, these could be called your solutions to the equation. They could be called stuff like roots. They can be called the zeros. They can be called the x-intercepts. They all mean the same thing. They are the solutions to this equation right there. So the roots, the zeros, the x-intercepts, the solutions, it's all the same thing. The solution to this equation is 5 plus or minus root 61, which is two answers, 5 plus root 61 and 5 minus root 61. All right, example number 2. We're going to solve x squared plus 12x equals negative 11. All right, so there's a little bit of a difference between the last problem. Up here, we started with 0 on this side. Over here, we got negative 11 on this side. All that's happened is the number that was over here already got moved for us. So they already did our first step, which was nice of them. So what we're going to do is we're going to just start up with the next step. The next step is to take our b value of 12, divide it by 2, square it, and then add that number to both sides. So that's called completing the square again. So this side, we're going to get x squared plus 12x. We're going to add a number to that side to complete the square. And on the other side, we're going to get negative 11. And then we're going to add a number that completes the square on that side. So what number completes the square? Remember, we take 12, we divide it by 2, and then we square it. So 12 divided by 2 is 6, and 6 squared is 36. So that is the number that we are adding to both sides of the equation. I'm going to add 36 to this side. The addition property equality says that I have to add 36 to the other side when I do that. So I've added 36 to both sides. Next step, we need to change this into a perfect square, a perfect binomial square. All right, so what number did we square? We squared 6. So this is going to be x plus 6 squared. On the other side, we've got 36 minus 11, which would be 25. Next up, now we've got this done. In the last unit, we would have taken the square root of both sides. So that's what we'll do here. Square root of that side, square root of this side. So if I've got x plus 6 squared, square rooting is the opposite operation of squaring. So they get rid of each other. And we just have x plus 6 over here. On the other side, do not forget your plus or minus. Anytime you take the square root of both sides, you have to add that plus or minus. And the square root of 25 is just 5. So that one did reduce. You have to reduce if it's possible. Next, we will subtract 6 from both sides. And we get x equals negative 6 plus or minus 5. Now, since this is a whole number, we can give the actual two answers. One of the answers would be negative 6 plus 5, which would be negative 1. The other answer would be negative 6 minus 5, which would be negative 11. So our two solutions to this equation would be negative 1 and negative 11. We would also call those the roots. So the roots of our equations are negative 1 and negative 11. Those are the zeros. Those are also the x-intercepts if we were graphing this. Last one for this type of problem, example 3. We're going to solve x squared minus 14x plus 5 equals negative 46. All right, again, we need the x squared and the 14x isolated on one side of the equation. So we're going to move this negative 5. I'm going to subtract 5 from that side and subtract 5 from this side. So that gives me x squared minus 14x. I'm going to leave a little bit of a blank there because I'm going to need to add a number to both sides on my next step. So I'm going to get ready for that. Over here, I get negative 51. And then I'm going to leave a blank on that side. All right, so we've moved the c value to this other side and then combined it with the negative 46. We got negative 51. Next step, we are going to complete the square. So I'm going to take this negative 14, divide by 2, and square it. So negative 14 divided by 2 is negative 7. And negative 7 squared is 49. So 49 is the number that I have to add to both sides of my equation. So I add 49 here. You're always going to add because anytime you square a number, it becomes positive. So this is always addition here. I'm going to add 49 here. All right, now we simplify on this side and we find our binomial square on that side. So on this side, our binomial square, the number that we squared over here was negative 7. So this is x minus 7 squared. On the other side, we've got negative 51 and positive 49. That would give us negative 2. All right, our next step is to take the square root of both sides. Some of you might see the problem that we're going to run into in a second. Wait for it. All right, so here we're going to square root x minus 7 squared, which is x minus 7. On the other side, plus or minus square root of negative 2. Square root of negative 2. Ooh, that's a problem. Add 7 to both sides, and I get x equals 7 plus or minus the square root of negative 2. But there's a problem with that. Negative 2 does not exist. You cannot have negative square roots. So we would say for this problem, at least for this section, is there is no real solutions. Or we might also say there's no real roots, or there's no x-intercepts, or there's no real zeros of this equation. So all 4 different ways to say the same thing. Now coming up in another lesson, we're going to find out that we can find the imaginary answers. There's no real answers, but there's imaginary answers for this one. And we'll get into that on another lesson. But for right now, we know that there's no real solution. There's an imaginary one, but there's nothing that's real, because you cannot have the square root of a negative number. All right, last thing I want to do is I want to look at going back to graphing and how this applies to graphing. So I got you a graph all made here. So here's our graph. And on this graph, on your homework, you're going to get stuff like this. And I want to find a couple things on here. I want to have it written in vertex form. I want the vertex, which we will have because we did vertex form. So I want the vertex. I want the y-intercept and the x-intercept. All right, so we're going to look for those values. You might notice that we already have our y-intercept. If you remember from standard form, my lights just went out. Hello? That was weird. All right, I'm not going to redo this because I've gone this far. If I don't move around enough, my lights go out. So that was not a disaster. All right, so anyways, we're back with the lights on. Oh, gosh. So in standard form, we notice here that we've got this value of 6, and we said that was our y-intercept. So we already know that our y-intercept is going to be the value 0, 6. So we already got that answered. And if I wanted to, and I was feeling saucy, I could go up 1, 2, 3, 4, 5, 6, and know that I'm going to have a point on my graph at 0, 6. All right, vertex form. Let's convert this to vertex form. Our steps, again, from last lesson, is to subtract 6 from both sides. Boom. Subtract 6, subtract 6. I get y minus 6 equals x squared plus 4x. Next step, I'm going to complete the square. I'm going to take 4, divide by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. All right, so 4 is the number that we're going to add to both sides. So I do y minus 6 plus 4 on that side. And on the other side, I do x squared plus 4x plus 4. Next, I'm going to simplify this side and get y minus 2. On the other side, I'm going to find out what perfect square did I make. Well, the number I squared was 2. So this is the perfect square of x plus 2 squared. And the last thing I'm going to do for vertex form is to add 2 to both sides. So I've got y equals x plus 2 squared. And I'm going to add 2 to this side and add 2 to that side, and I get plus 2. So vertex form is y equals x plus 2 squared plus 2. All right, and we found out in the last unit that our vertex would be the opposite of this number and this number. So this would be negative 2, comma 2. So my vertex is at negative 2, so I go back 1, 2, and up 1, 2. There's my vertex, which remember means the axis of symmetry is going right through it. There's my axis of symmetry. My axis of symmetry is x equals negative 2. Now the axis of symmetry is really nice because it tells us that if I've got a point that is 2 away from the axis of symmetry, I've got another point 2 away on the other side because it's a mirror image on either side. So we've got those 2 points. Let's get one more point. Let's plug in negative 1 right here. So if I plug in negative 1, let's see, I get negative 1 plus 2 squared plus 2. So negative 1 plus 2 squared would be 1 squared plus 2, and that would be 1 plus 2, which is 3. So I know that if I plug in negative 1, I get a y value of 3. That would be this point right here, which means I have another point on this side because of the axis of symmetry. and then I get my parabola. Oh, that's not bad. That's pretty good. See, that was freehand. That's freehand. That's skill, right? Well, it's a pretty good skill. I'm working on it. Anyways, so we got our parabola right there. Beautiful. Now, where's our x-intercepts? Well, this thing turns around before it ever gets to the x-axis. So there are none. So on this particular quadratic, there is no x-intercepts because our parabola never gets to the x-axis. All right, that's all I have for you today. That should get you through worksheet 2. Thank you. Have a good day. Bye-bye.